gon' give it to you. Fuck, wait for you to get it on your own. X gon' deliver to you. Knock, knock, open up.
What's up, nerds? Welcome back to Tea Time with your favorite software engineer. If you guys haven't already, if you guys are new to the channel, check me out, subscribe. I post LeetCode videos a few times a week. I also have a Slack channel where I post problems every day for us to discuss and solve, so that invite link is in the description. And then today we're going over subarray product less than K. So there's a lot of these like subarray problems. So here's another one. Subarray sums divisible by K. Then there's like subarray sum equals K. So you're going to notice a pattern with these problems. I would also recommend doing subarray sum equals K. If you haven't done that one first, it's a little bit easier. So you're basically going to be using the same concepts. You need to be able to notice these patterns. So that's like the intuition behind this problem is you kind of just have to pick up the pattern already. So we typically use sliding windows in these subarray products because they're contiguous subarrays. So we're sliding the window into the subarrays. So the description reads, you are given an array of positive integer numbers. So positive is pretty important. I'll explain later why. Count and print the number of contiguous subarrays where the product of all the elements in the subarray is less than K. So they just want us to return the number, so we don't have to actually like store all these numbers in an array. And so, for example, 10 is less than 100, so we would have 10. And then 10 and 5 is 50, which is less than 100. So we'd have 10. We would have 5 by itself as well. So we would have to add 5 at that time and 10 and 5. And so then we'd go to here. So that's 50 times 2, which is 100. So it's not less than K. So what we would do is while it's less than, so we're going to have product equals 1 because we need to multiply something by 1. We need to multiply 10 by 1 to get 10 to start off. And so while we're going to execute this statement, while product is greater than or equal to K, we're going to, we would need to get rid of 10. We're going to be using a sliding window. So we're going to have a left pointer and a right pointer. We want to move left 1 over. So how would we do that? We would just divide product by nums of I. So that would basically slide the left pointer over, or not nums of I. Well, it would be nums of left. I guess you could use nums of I too. And we would also have to increment left. So that's what's sliding it. Dividing it is removing it from the product variable, and so then we would just have 10 in product, and we would go again. And so left is now here, and we would move right as well. So that's how we adjust for it. But how do we add increment them correctly? So for example, in this one, we have 5 times 2 is 10 times 6 is 60. So the correct amount of arrays we'd want to add is 5, 2, 6. Somebody's called me. And 2 and we would want to add 2 and 6 as well. So we'd want to add 6, 2, 6, and 5, and 2 and 6. So that's the 3 subarrays we want to add. How do we get that? We would do answer plus equals, I always do that, right minus left plus 1. So let's go over this, why this works. We have right is 3 minus left is 1 plus 1, we get 3. So that's how we add all the correct subarrays for this iteration. So basically that's how it works. We're just moving the pointers in the sliding window where we need to, adding the correct amount to the answer. And now let's just code it out. We're also going to have a base case. So if k is less than or equal to 1, since the numbers are always going to be greater than 0, so if it's 1, the minimum is 1, it would be impossible for it to ever be less than 1. So base case, if k is less than or equal to 1, we would just return 0 since it's impossible. And then we just want to we need to create our variable, so let's create product equals 1. So like I said, we want to create 1. We have our left pointer, set it to 0, and our answer, so that's also 0. And then we're just going to loop through. I'm actually going to call this right. Right left then nums.length right plus plus. Okay, so first thing we want to do is multiply product by nums of right. So we're multiplying it by nums of right because that's the one we're moving. Nums of left is the one we're dividing by because it's the left side. So, and then we need to check to see if product is greater than or equal to, I almost put 100. We need to divide it by nums of left, so we're getting rid of the left one because we already calculated all the subarrays that it can possibly exist in. We want to move the left pointer over, so we're calculating all the new subarrays. And then we're just going to add the right minus left plus 1. So this is calculating all the new possible subarrays. The reason it works is because as you increase right, the possible number of subarrays also increases. So if we had a fifth number, if we had 10, 5, 2, 6, 3, I know that's not less than 100, but let's say it is. For this instance, we would want to add 3. So I'm going to change the color. We would want to add 3, 3, 6, 3, 6, 2, and 5, 2, 6, 3. So it's basically just increasing by 1 each time. So we need the indices to calculate this. So we have right, and where did I have? Oh, at 5 left. So it is 4 minus 1 plus 1. So we get 4. And then we just need to return answer. So hopefully that makes sense. This is just a sliding window problem, and then you need to do the calculations, figure them out how you're going to add. I think the trickiest part is this part right here. Being able to figure that out, how to correctly add all the new number of subarrays, because we're not just adding one subarray at a time, we're adding all the possible permutations basically. So let's submit this. And so this is, let's go over the runtime now. So this is just a for loop. So it's O of n runtime, and we didn't use any data structures. So just O of 1 space complexity. I believe that was the it's same runtime and space complexity for subarray sum equals k. So you should notice like patterns with these problems. I'm gonna do this one next today. So I'm sure it's another sliding window problem, but that's all I got for you guys. I hope you guys enjoyed the video and learned something, and if you did, smash that like button. I'll see you in the next video.
Yeah.